Okay, so today I'm going over Module 11.2, Simplifying Radical Expressions, and I'm going over the Explore. We are on page 543. So we're just going to jump right into it, and it says, in previous courses you have used properties of integer exponents to simplify and evaluate expressions, as shown here, for a few simple examples. So if I had 4 squared times 4 to the 3rd power, we know that we can add those exponents and get 4 to the 5th power. And then 4 to the 5th power is 1024. If we had like 4 squared all to the power of 3, then we know that we can multiply those exponents and we would get 4 to the 6th power. And then 4 to the 6th power is 4096. If we had a quotient like this, if we had 4 over x, we know that we can distribute that exponent to both the numerator and the denominator, and I would get 4 cubed over x cubed, which is 64 over x cubed. For this one over here, we have 4 times x, all squared, and again we can distribute that exponent to the exponents of the product inside. And so we would get 4 squared times x squared, and 4 squared is 16, so we get 16x squared. For this one here, if we have 4 to the power of 2 divided by 4 to the power of 3, we can subtract the exponents and we actually get a negative exponent. And then remember, a negative exponent becomes positive when you bring it to the bottom, so that's why we brought 4 to the 1st power to the bottom, and we get 1/4. So we are going to use some of these properties. And it says, now that you have been introduced to expressions involving rational exponents, you can explore the properties that apply to simplifying them. So if it says, let A equal 64, B equal 4, M equal 1/3, and N equal 3/2, and it says evaluate each expression by substituting and applying the exponents individually as shown. So we're going to take these values that are given to us here and plug them in. So that's what I'm going to start doing. I'm going to do this substitute column here and just substitute them in. So A is 64. So we have 64. M is 1/3. So 64 to the 1/3 power. And then all that is to the power of N, which N is 3/2. Okay, now I'm going to substitute into A to the power of N. So we have A, which was 64. And then we have N. So the exponent of N is 3/2. And then M is the exponent on bottom, and so that's a 1/3. And then I have A over B all to the power of N. So let's see. A is 64. B is 4. And N is 3/2. Okay, so I substituted them in, and now I'm going to do this column that says to simplify. So if I'm simplifying this, 64 to the power of 1/3 is the same thing as the cube root of 64, which I know is 4. So I have 4 to the power of 3/2. Okay. Here, if I'm simplifying, I have 64 to the 3/2, and 64 to the 3/2 is 512, and 64 to the power of 1/3, well, we just did that in the one above here, and we know that 64 to the power of 1/3 is 4. For this one, 64 divided by 4, we get 16, and then that's to the power of 3/2. So what's my final result? Let's see. So 256, the way we got that was 64 times 4 was 256, and that has an exponent of 3/2. So 256 to the power of 3/2 is 4096. we could have also thought of that as the square root of 256 all cubed. Okay, for this one here, 4 to the power of 3/2. That is, another way to think about that is the square root of 4 cubed. So the square root of 4 is 2 cubed, so 2 cubed is 8. Okay, 512 divided by 4 is 128. And then thinking about this as a radical, I have the square root of 16, and I'm cubing that. So the square root of 16 is 4. 4 cubed is 64. So now if I go to part B on the next page, it says complete the table again. This time, however, apply the rule of exponents that you would for integer exponents. So I copied these values from the page before. A was 64, B was 4, M was 1/3, and N is 3/2. And we're going to substitute these in. So for the first one, we have 64 to the power of 1/3. 64 to the power of 1/3 times 64 to the power of 3/2. And then our rule that we would do is we would add those exponents. So if we add those exponents, we have 1/3 plus 3/2, which is 11 over 6. So 64 to the power of 11 over 6 gives us a result of 2048. We could have thought about this as the 6th root of 64, and then that raised to the 11th power. So the 6th root of 64 is 2. 2 to the 11th power is 2048. For this next one, we could think of this as 64 times 4 to the power of 3/2. And the rule that we would do is we would distribute that to each of these, and we would get 64 to the power of 3/2 times 4 to the power of 3/2. And so if I simplify 64 to the power of 3/2, that's the square root of 64 cubed. So the square root is 8. 8 cubed is 512. And then the square root of 4 is 2. 2 cubed is 8. So I'm going to have 512 times 8, which is 4096. Okay, for this next one, we have A, which is 64, to the power of M, which is 1/3, to the power of N, which is 3/2. So I would multiply those exponents, and if I do that, I get 64 to the power of, I could think about this as 3 over 6, but isn't 3 over 6 just 1/2? So I'm going to reduce that to 1/2. So 64 to the power of 1/2. And that is the same thing as the square root of 64, or 64 to the 1/2, however you want to think about that. And that is 8. For this one, we have A, which is 64, to the power of N, which is 3/2, and then 64 to the power of 1/2. And I would subtract those exponents. So I would get 64 3/2 minus 1/2 is, sorry about that. I just caught myself making a mistake right here. So on bottom, I'm plugging in M, and M is 1/3. So I would have 64 to the power of 3/2 minus 1/3, which is 64, and you have to get common denominators. And when I do that, I would get 7/6. So the 6th root of 64 is 2, and 2 to the 7th is 128. For here, I have A, which is 64, B, which is 4, and then to the power of N, which is 3/2. And I would distribute that exponent to both the top and the bottom, the numerator and the denominator. And then 64 to the 3/2 is the square root of 64, which is 8. Cube that, which is 512. And 4 to the power of 3/2 is the square root of 4, which is 2. 2 cubed, which is 8. So 512 divided by 8 is 64. So I'm just going to give you a quick recap using these here and just go over what do we do when we have this. So if we have a to the m times a to the n, we could say that's a to the power of a plus n. For this one here, we would distribute them because that's a product of a power. You distribute that power to both of them. For this one here, you'd multiply that, and so that would be a to the power of n times m. We multiply those. Here we would get a to the power of n minus m, because you can subtract the exponents when you're dividing the bases. And here we would distribute this to both and get a to the power of n over a to the power of m. So that's how you use those properties.